I know Bailey Hydraulics has recently introduced its AT hydraulic cylinder. Could you maybe kind of start talk about how or why the development of this particular cylinder came about? Was there maybe something in the industry you guys were looking to provide a solution for or anything like that?
Yeah, and just to clarify, the AT line has been out for a while.
Oh, okay.
What this is an upgrade in the or a fleshing out of the whole option. So we had
Okay.
2 inch bore and 3 inch bore available, two and a half and 3 inch bore. But what we've done now is we've released our 3.5 and 4 inch bore cylinders. And it's a great question on the initial onset because what we had done is it's one of those better mousetrap conversations that there has been tie rod cylinders out in agricultural applications for decades. So in the last 7, 8 years, Bailey tried to rethink the traditional tie rod cylinder. Is there a better way to do it? We looked at all kinds of different material aspects, ways that we could essentially move our clients that we're working with into a better option while keeping cost in line. There's welded clevis mounted cylinders have been out there for, again, decades as well. However, they're significantly more expensive in most cases,
Mm.
require a different skill set in terms of manufacturing, but they're also a different skill set in terms of working on them. And so it takes just a different mindset when you're working with a welded cylinder in a lot of cases. So we try to go to a simplified design that would be user-friendly in the field and provide the upgrade of a welded cylinder suitably strong enough to work in the same applications that a tie rod cylinder would work. So the genesis of the AT was really based on a brainstorming session of, hey, how can we do this better and what can we put out there? So once we had some concepts in place, we went through the whole engineering testing process. Bailey has, maintains a good testing center that we put everything through its paces and can confirm all of the theoretical calculations. So we did put these through their paces, and we've come up with a design we've been very successful with over the past 6 or 7 years. Now the design incorporates a snap ring for the gland. So what that is, that's where the rod comes in and out.
Mm.
So the snap ring is you can use a snap ring tool to remove it, one snap ring, and then the whole gland assembly can come out. So it's easy to be rebuilt in those smaller bores, the 3, 2.5, and 2 inch cylinders. They're drop-in replacements for tie rods, which is one of the big key things that we wanted to do when we went to this upgrade to the AT from a welded traditional versus the tie rod. Tens of thousands of machines out there with tie rod cylinders in them. So if we wanted to be able to service those machines, they're fairly universal in their designs and their lining up of the port locations and whatnot. So the AT is a drop-in replacement for the tie rod cylinder. It has dual ports on the base end. So that means that just like a tie rod cylinder, you have an option of a side port and a top port, and it's got a side port on the rod end. It is in the same configuration of what a traditional tie rod would be. Dimensionally will fit in the same place. Hose management is relatively easy to interchange. So again, the whole concept, that better mousetrap, keeping a cost-effective product that would enable a machine builder or a field replacement to upgrade their equipment and to have a piece of machinery that looks more modern. The aesthetics are better. It also, I'm getting ahead of myself perhaps, but it also allows, there are a lot of applications where you have entanglement issues or contamination issues. The tie bolts around a traditional tie rod cylinder, it's two pieces of cast iron that are held together by the 4 bolts with the nuts holding all together. So the welded design removes all those places where sticks, rocks, things can get wedged in between the tube and the tie bolt.
Mm.
And it also, in places, think manure handling or cleaning out a chicken house or something along those lines, you have less places for contamination to get lodged and stick. So it's easier from a wash down perspective to clean the equipment up at the end of the day.
And so, you were already kind of touching on the design, but maybe, are there maybe other aspects of the cylinder's design that kind of help make it different or more unique in the market than other, or if there are other similar types of cylinders available?
What really kind of I think stands this one out is that the effort that's been put into simplicity from a replacement and the effort that's been put into the durability of the cylinder. We put it through its paces pretty hard. When we launched these new lines, the 3.5 and the 4, the reason that we had not previously done so is we weren't comfortable with the original designs in the larger bore and pressure applications. So it took us a few more years to kind of get all the engineering worked out to where we were comfortable putting it out there and happy with the product after its testing regimen. So what we've done in the new release is a 3.5 and our 4-inch bores incorporate induction hardened chrome rods. So the induction hardened chrome rods do a better job of column load capability. In other words, they're less likely to bend or break because of the heat treating that's on there. Another side benefit of that, though, is that they're also an induction hardened rod with chrome on there. It's less likely to chip and have issues with the plating later if it's got things that are hitting it. Because being a solider surface, a harder surface, things tend to ricochet off rather than indenting and creating a little dimple, which then can create a place where the chrome can rust and grow out. We've also gone to a threaded gland on the larger bore sizes to enable it to be able to handle the higher pressures or the higher forces that are involved at the higher pressure end of things.
Mhm. Okay. All right. And so you were touching before on, some of the benefits this cylinder can provide, but were there additional benefits or, when or how might somebody go about, deciding which type of
Sure.
this version versus more traditional previously used cylinder types?
Yeah, that's a great question because it's one that we tackle regularly. And one of the things that we are trying to promote here with this is the improvement and the adoption of it. So the previously mentioned improvements aren't immediately recognizable when you look at the product. So it's really having people look at things a little bit differently than what they've done. It's so easy to say, well, a tie rod cylinder has been here for however long. I don't want to change it out because I know it works. Having the option of here dropping, we've made it very simple to drop in, replace, and every application that we have put this into on a trial basis has gone to full production later. So it's almost universally adopted once it is tried. So it's really overcoming the concept of, well, welded cylinders are a lot more expensive and they don't quite fit the way I want them to. Looking at this product as, instead of in that welded cylinder category, really it's just a different version of a tie rod cylinder. And really that's getting that mentality in place that any design, application design engineer or machine builder or even a field replacement out there should consider this product as an upgrade at a very affordable price to what they're currently using in the tie rod cylinders.
In specific applications like agricultural equipment or construction equipment, or are there other machines, and like what specific benefits to those applications can it provide, and are there other target markets, I guess, or
Yeah,
applications you see for it?
yeah. Again, a good question. So the initial concept, of course, was agriculture, as that's the highest percentage of tie rod cylinders and machines reside in the agricultural market. That said, that there is a considerable space out there in other places that have, I wouldn't want to put this into a high shock load, heavy impact. It's not designed for those kinds of applications. What it is designed for is the placing something into a, just positioning. There's a lot of applications that require something to be positioned. If you're using a slip form paver for putting a curb in or something, sometimes it'll just have a positioning cylinder. This would be a great application for something where it's just a positioning kind of a thing. If we're talking about going into a high impact heavy shock load environment, there are much better options that we offer that I would recommend this one other than this one. So this is going to be that light to medium duty application, agriculture in mind, because that's the highest area that there is. But for a lot of folks that would not consider going to a tie rod cylinder, they want to go to a welded kind of setup, but they don't have that high impact kind of an application. This would be a great choice to be considered because it's a lower entry point as far as the cost is considered, and it will do the job for as long as any other product would do it out there, if not better. So we've got an application split there. We industry wise, we had thought about agriculture. That was first and foremost in our mind because that's the market that most tie rod cylinders are put into. That said, I see them all over the place. I see them in all kinds of different locations and all kinds of machinery across the country. So anytime that you would consider using a tie rod cylinder, you should consider using this as well.
Okay. And so just to kind of help wrap up our conversation, do you maybe foresee this type of cylinder becoming more popular within certain applications, or, those new possible equipment types that traditional tie rod cylinders weren't used previously?
I certainly hope so. I think from a,
Mhm.
I think as it gets adopted more and more into the marketplace, it will become we anticipate this one to continue to grow, this line to continue to grow at a steady rate, and at some point we expect it to really take off. And that tipping point for us is going to be, we believe, as more machinery gets modernized and electrification continues to work into the industry, people are trying to find tighter spaces to make more compact machines.
Um,
These fit into a tighter envelope. They're doing the
yeah.
same work that fit into a tighter envelope because you don't have the big, heavy castings to work with. You're now down just to the tube.
Mhm.
So it is, in the base end, it's recessed into the tube area. So from a spatial perspective, as machinery continues to get more, compact, everybody's making things smaller. I think that these will find a better home in those types of applications for sure.
Mhm. Okay, great. Well, thank you so much for taking the time to speak with me today and provide some more insights on these, update to the AT hydraulic cylinder line that Bailey has done.